Today in this video we are going to study about the application of the differentiation, and in this lesson 3.3 we will study about the maximum and the minimum values. Our objective is to identify the relative extrema on the graph, find the increasing and decreasing intervals of the function in a closed and the open interval, and justify the conclusions about the behavior of the graph or the function based on the behavior of the derivatives. Similarly, we will see what is the difference between the absolute and the local minimum and maximum, and what are the critical numbers and how to find the critical numbers in a graph. Let's get familiar with the terminologies over here. Open interval. Open interval means that exactly those points are not included. So let's suppose I am showing you a graph over here. Okay. So let's suppose this is a point. So starting point is A at the x-axis and the ending point is B at the same x-axis. Now, this is, you can see that this shaded point shows that the point of the A is included. Yani if this y value is 1, so you can say that f of A is equals to 1. Similarly, if this value is, let's suppose it's 10 over here, so you can say f of B equals to 10. Because these points are included. But rather than making like this, or the interval, if you will show, this is the closed interval from A to B. And it will be shown by this big brackets. Similarly, if this points, let's suppose rather than the points at the A and B are open. This shows that these points are not included, which means that you are coming closer to the A, coming closer to the A, but exactly at A, the function is discontinuous. Okay, you cannot say. So the function at the A in my scenario, in the current scenario, is undefined. And we have studied such kind of the things already in previously in the limit section. So these points are not included. So when the points are not included, so you will see the interval you will show the interval by the small bracket. So you will write A to B. So these are the points which are not included. So come again. For example, so here in the figure A, the initial and the ending points are not included. Initial ending points are not included. And remember, if the points are not included, whether they are at the peak, okay, they are at the highest of the graph, highest points of the graph, or the lowest point of the graph, you will say that there is no maximum, no minimum. Okay, so only we can show the minimum or maximum values when the points are included. So you might say that maybe this point is the highest point. But do you know what this point is? Yani what is let's suppose this value over here, it's 10. But what is this value is equals to? You cannot just judge it, because exactly you don't know whether it is 9.1111 or 9.0001 or 9.9999 or what this point is, because on the x-axis you are coming closer to the points which is coming over here. Let's suppose this is a B point. So you are coming closer to the B point, but exactly at the B point is discontinuity. So you don't know that what is this height equal to. That's why although this point is the highest point of the graph, but you won't say that there is the highest point. You will say that undetermined. You cannot determine that exact value. So you will say there is no maximum or no minimum if the points are open. Closed interval. Closed interval, when you talk about the closed interval, so these are the points which has to be included. You have to show the included points. Now, in the included points, yes, this is the highest point. So let's suppose this is B point, okay? So on the B, you have the maximum at Y value 10. So if this point is included, you can say that there is a maximum or the minimum value will be determined, can be determined. And what that those points will be, we don't know. We will discuss later on. But I am showing you that the maximum or the minimum values at the closed interval can be determined, but at the open interval cannot be determined. Now, what are the extremas? So there are two kinds of extreme values. Okay, so let's see over here. Remember, when we talk about the extrema, it means collectively you are talking about either the maximum or the minimum. This shows you that there are many maximum or many minimums. Okay, so you can say maxima. Maxima means many points. Okay, shows that many points. And if I talk about maximum, means mum, if it is ending with it means about a 1 point we are discussing or we are talking. So when we talk about the extrema, there are two types of extrema. One is named as absolute extrema and the other is named as local extrema. Now local has another name which is called relative extrema or local extrema. Similarly, absolute extrema can be global extrema or absolute extrema. So in your textbooks, we are dealing with absolute and local terminologies. But if you see somewhere global or relative, you should know that what they are talking about. So again, there are two kinds of extrema. One is said to be absolute and the other is said to be local. When we talk about the absolute extrema, it means that the highest point of the graph. Completely. Absolute maximum means highest point of the graph. And absolute minimum means the least or the lowest point of the graph. This is said to be absolute. Later on, we will discuss what is the difference between the local or the absolute. Right now, keep it in mind that when we talk about the absolute maximum, it means we are talking about the highest point of the graph. When we talk about the absolute minimum, it means we are talking about the lowest point of the graph. Again, look at the graph. Okay, look at the graph. Now, just identify where is the highest point of the graph. So you can see this is the highest point of the graph. Why not this? Because this point is lower than this point. So this is the highest point of the graph. So you can name it as absolute maximum. And you can see all other graphs, all other points, even these points, they are lower than these points. Okay, so where is the absolute minimum? So not this point, because this point is the lower point, but the lowest point of the graph is this one. So this is the absolute minimum. So over here is the absolute minimum and this point is the absolute maximum of the graph. So remember that how to find the absolute maximum or absolute minimum of the graphs. And collectively maximum and minimum are said to be extrema. Over here, look at this one now. Now here, look at the ending points. Okay, the graph over here, it is increasing, means keeps going on. Over here also keep going on. Where it will stop, you don't know where it will stop. That's why if the last points are not included, you will say there is no absolute maximum. But look at the graph over here. This is the lowest point of the graph. So that's why at this point you will say that this is the absolute minimum. Now look at the figure B. Over the figure B, this point is going down and down and down and down. Similarly, this point is going down and down, and where will they stop? You don't know. It's an ongoing graph. That's why there is no absolute minimum. But there is a point over here. It is the highest point of the graph. That's why you will say that this is the absolute maximum of the graph. Now there is a theorem, extreme value theorem, that if the function is enclosed in a closed interval, okay, so you must have absolute maximum or absolute minimum of the graph. Means the main condition is that the graph's starting point should be known and the ending point should be known. If the starting point and the ending point of the graph are known, you will have the absolute minimum and you will have the absolute maximum. So this is absolute maximum and this is absolute minimum. Now let's talk about what is meant by local or relative extrema and how they differ from the absolute maximum or minimum. Now look at the graph. Okay, so here the graph. Now what have you seen? That this is the turning. This point is the turning point, if you can see over here. So the turning points where the increasing interval, because the graph is increasing, and all of a sudden after reaching to a peak point, it started decreasing. So that point where the increasing changes into decreasing is said to be relative. Now increasing changes into decreasing, that is said to be local maximum or relative maximum. Now if decreasing changes into increasing, so the graph is decreasing, all of after this point they started increasing. So at this point you will have the relative minimum. Now the turning point. So the most important thing is at the turning points you will have the relative extrema. Okay, relative, either it could be relative maximum or it could be relative or local minimum. Now look at this. No concern, okay, whether it is the highest point or the lowest point is not our concern. Mostly it has to be a turning point. So this is the turning point. Where is the highest point? Over here. So you can see there is a mountain, like this is the peak mountain. So if it is a mountain, you will say it is a local maximum. So it's a local maximum. Over here, look at this one. It's a kind of a valley, right? So over here, what is happening? Decreasing changes into increasing. So this is a kind of a valley. That's why it is a local minimum. Okay, so understand that what is the difference between local maximum and minimum. Local maximum and minimum, they are actually the turning points. Now, let's suppose the graph has more turning points. No problem, you will have more relative maximum and minimum. So any turning point is a maximum, local maximum or a local minimum. Whether, look at this graph, okay, look at this graph. Here, although the graph is conical turning, yani there the turning point is conical, but yes, it is a local minimum. This point is a local maximum. This point is a local minimum. So you could have a number of local maximum and minimum, no matter they are at the highest point or lowest points, but they should have the turning points. Now have a look over here. First of all, look at the graph and let's try to determine, do we have any absolute maximum or do we have any absolute minimum? Let's understand about the behavior of the graph. Look at the graph over here, the last point, okay? This is the ongoing graph, means it is going up and up and up and up and up and up. When it will start, we don't know because it's an ongoing graph. So there is no, you don't know where is the highest point. So you will say no absolute maximum. Okay, why? Because it's the open interval. Okay, now look at the last point. Okay, similarly over the last point here. Let's see like this. Okay, so it's going down and down and down and down and down. Ignore this one. Okay, down and down. It means the graph is going down and down and down. You don't know when it will stop. Okay, so that's why there is no absolute minimum. Okay, now let's talk about the local maximum or minimum. So any turning point could be a local maximum or a local minimum. If it is a peak point, it's a local maximum. So let's start from here. What is it? It's a maximum or minimum? Yes, it's a minimum because it is a valley. Okay, this is a peak, this is a turning point. Okay, again it is a turning point. Is it a maximum? Like a mountain, it's a peak, so it is a maximum, local maximum. Over here again it's a kind of a valley, right? So here again it's a local minimum, and here this is again a kind of a peak, right? So whenever you have a peak, you will say that this is my local maximum. So no matter it's a conical turning, it's a smooth turning, but you will have the local maximum and local minimum at the turning points. Now, the local maximum and minimum cannot be at the end of, yani you can't say if this is even a included point, right? So you can't say this is a relative maximum. No, the relative maximum always be in the middle of the graphs. The last points, if this is the included point, they could be only absolute maximum or minimum. They cannot be absolute maximum or minimum, can be in between or at the end of the graphs. But always the local minimum or maximum will be found in between the graph. Now there is another terminology, critical number. What is critical number? Remember that the critical numbers can be found only at the turning points. Can be found at the turning points only. Okay, and what do they say? Critical points are the points where the slope of the tangent line either be equal to 0 or it is undefined or not differentiable. Okay, either be undefined or equals to 0. So when we say slope of the tangent line, it means we are talking about the derivatives. So the slope of the tangent line or f prime of c, either it will be 0 or the slope of the tangent line is undefined. When the slope is 0, when you have a horizontal line. When the derivative is undefined, when the slope is a vertical line. Remember this thing. Now look at the first graph, okay? You have a very sharp turning. When you say about a sharp turning, you will say that the slope is undefined. Okay, now when you have a smooth turning, if you make a tangent line, you have a straight line, horizontal line, and the slope of a horizontal line is 0. And what is slope of a tangent line means? It means derivative. So critical numbers can only be found on the turning points. So at the critical numbers, they 100% they will be either relative or local maximum, or they will be 100% will be relative or local minimum. Number 1. Number 2, the slope of the tangent line will be equal to 0 or it will be undefined. So there is a scientist Fermat's theorem. Fermat said that the f of c could be a local maximum and local minimum. Okay, and this is a critical number of f. Now, critical numbers again where the derivative is equal 0 or undefined. Look at this. This is the sharp turn. So it is a relative maximum, a peak, right? And here sharp turn, it is the derivative is undefined. when the derivative is undefined but it is a critical number. Here, over here, this is a peak of a mountain. So again the derivative is 0 because the slope of the tangent line is a horizontal line. Over here, thus again it is a local minimum and the slope of the tangent line is 0. Here again you make a tangent line, it's again equal to 0 and it is a relative minimum. Over here it is a relative maximum and the slope of the tangent line is 0. So this is how you can understand that a critical number 100% be a relative extrema. Okay, it's a critical number. Okay. Now over here, increasing and decreasing intervals. Now increasing, in terms of calculus, a function always be studied from left to right. Yani you are studying here, starting from here to right side go. So what is happening? The graph is increasing, and if you make anywhere a slope of tangent line, let's suppose here, okay, so what have you seen? That if you make any slope at any point, the slope is increasing. Okay, the slope is positive. So wherever you will make a slope, make a tangent line over the graph, the what have you seen? That the slope is positive. Okay, so that's why if the slope is positive, it means the derivative is greater than 0. It means the function is increasing. Over here again you look at this one. Now, although this is the graph, again if you make a tangent line, what have you seen? That the slope is increasing. The slope is positive. So when slope is positive, derivative is greater than 0 and the function is increasing. Again, you are standing over here. What is happening? The graph is decreasing, decreasing, decreasing. And in other words, if you make a tangent line anywhere in the graph, you will see there is a negative slope. So the function is increasing when the slope of the tangent line is greater than 0 or positive. If the slope of the tangent line is negative, it means the function is decreasing. Next thing, again look at this one. Okay, here the slope is increasing. So the function is increasing, increasing, increasing. Over here, this is the local maximum. After this, what happened? It started decreasing, right? And after reaching here, at this point of value, again the function becomes 0. Over here, when you have the local minimum, then again the function starts increasing. After reaching to a certain peak, again where the function is a critical number or local maximum, the function again starts decreasing. So the derivative is positive or the slope of the tangent line is positive, the function is increasing. The slope of the tangent line is less than 0 or negative, the function is decreasing. Okay, over here, what is the connection of increasing and decreasing interval with the extrema? Again, when the increasing changes into decreasing, the point where the increasing changes into decreasing is said to be relative maximum. Okay, is said to be relative maximum. Similarly, if the point the decreasing changes into increasing, a certain point comes in between where the slope of the tangent line is 0. So that is the relative minimum. So when decreasing changes into increasing, you will have a relative minimum. When the increasing changes into decreasing, you will have a local maximum. Let's analyze the graph and try to find out the questions, try to find out the answers of the questions which are asked. Okay, locate any absolute extrema in the given graph. First of all, look at the graph. Okay, so the last point are not included because the included point should be shown by a very shaded point like this. Okay, so this scenario is not given. If this scenario is not given, it means that this is the ongoing graph going up and up and up and up. It means it's an ongoing graph. And similarly over here also it's increasing and increasing without bound. It means you have no absolute maximum. But what about the absolute minimum? So this point is the absolute minimum. Although it is a turning point, yes, it is a turning point, so it is also a relative or local minimum. Okay, local minimum. And it is also an absolute minimum. Get it? Next graph. Now again, the starting point is not included, the ending point is not included. It means we have no absolute maximum and minimum. Remember, in the open interval, we never have any absolute maximum or minimum depending on the behavior of the graph. But look at the graph. So look at the graph, but again, this is the absolute minimum. So minimum point is given. And yes, it is also a local minimum. So you can see that absolute minimum, local minimum can also be a absolute minimum or maximum. Next question. Now the two graphs, the 2 points are given to us and they are included and they are at the peak of the graph and they are the highest points of the graph. So you can say that absolute maximum is there where at f of -3 you can write the x and y value at f of -3 equals to what is the y value? Y value is 0. And similarly, at f of 3 equals to 0. What do you have at this point? This is the absolute maximum. Now, can these points be relative or the local maximum? No. Why? Because they are not the turning points. So, it's not necessary that always the absolute maximum or minimum be a local maximum or minimum. But this point is the lowest point of the graph. It is said to be the absolute minimum, and since it is a turning point, so you can name it as also local minimum. Now locate any absolute extrema. Now let's see here, okay? So what is the highest point of the graph? Seems to me this is the highest point, right? But again, it's going up and up and up and up and up. So I don't have any absolute maximum. Similarly, over here, it's going down and down and down. So I don't have any absolute minimum. So no absolute maximum, no absolute minimum. Now look at this graph. Here the starting point is given to us and this is the peak of the graph. So this is the absolute maximum. But you can't only write absolute maximum. What are the point? F of, what is the x value? F of 1 equals to, what is the y value? 1. This is the absolute maximum. Now what is the absolute minimum? Absolute minimum is here. And this is the lowest point of the graph. Okay, so what is the absolute minimum? So let's try this one. Let's suppose it's 0.5 here and this is 0.25 maybe. Okay, so you can write f of 3 equals to 0.25 is the absolute minimum. None of them is the relative or the local maximum or minimum. Okay, now here is the graph. Do we have any absolute maximum? No. This is the highest point of the graph. So this is your absolute maximum. And also this is the peak of the graph, a turning point. So this is also a local maximum. What is this point? Let's see here. What is the x value and y value? So at f of, this is the 0. Equals to, what is this point? If this is 5, this is 10. So maybe this is equals to 9. Okay. Now let's see what is the local minimum or absolute minimum. Okay, so this graph is ongoing graph going down and down. From this side also it's going down and down. It means we have no absolute minimum. No absolute minimum, and we don't have no local minimum because we don't have any such kind of the turning. That's why no local minimum and no absolute minimum. Look at this graph. Do you have any absolute maximum? Look at this. This graph is ongoing graph going up and up. From this side also going up and up and up and up. So we have no absolute maximum. So this is the first thing. We have no absolute maximum. Now look at this. What is this? This is the lowest part of the graph. So we have absolute minimum. And also this is the turning of the graph. So we have the local minimum also. And what are the point? F of 0, because this is 0, equals to 0 because the y value is also 0. Let's try this graph. Determine if the graph consists of both absolute and relative extrema, and support your stance and determine the coordinate points of the extrema. Okay, so first of all, the first thing is find out what are the highest point of the graph. So you can see this is the highest point of the graph, right? But this is not included because it's the open interval. So you will say that no absolute maximum. Okay. Now find out if there is an absolute minimum. What is the lowest point of the graph? This is the lowest point of the graph. So yes, there is an absolute minimum. So let's try to find out what is absolute minimum. So what are the coordinates? The x value is 1 and the y value is, let's see here, negative 15. Okay, so you can say f of 1 equals to negative 50. This is absolute minimum. Now find out what is the third task. Find out the local maximum and find out the local minimum. So find out all. Okay. So this is the local minimum. Let's see here. This is local minimum. This is also this is local maximum because turning point, and this is local minimum. So all the peaks are the maximum of the turning point and all the valleys, okay, like this are the minimums. Okay, so what is this point? Local minimum, we already found f of 1 equals to negative 15, 1. F of 1 equals to negative 15. What about this one? This one is f of 6 equals to 10. So f of 6 equals to 10. So these are the local minimums and this is the only local maximum. So local maximum, go down, the x value is 4 and y value is 40. So f of 4 equals to 40. So this is how we find the local maximum and local minimum of the graphs. Let's try this one again. So here again ongoing graph going up and up and up. It means open interval. Over here also going up and up and up. We don't know when they will start, when they will stop. So no absolute maximum. Okay, no absolute maximum. Okay, let's try this one. This is the lowest point of the graph. Okay, so let's see here. It's negative 1. Here it's 1. Here it's 2. Okay, so this is the lowest point of the graph, which is absolute minimum. Okay, absolute minimum. What is absolute minimum? F of, let's go over here. It's 1. F of 1 equals to negative 1. And this absolute minimum is also the local minimum. Now, do you have such kind of turning? Right? This kind of turning for the local maximum? No, in this graph we don't have. So you will say no local maximum.